Today, we are diving deep into the engine that runs our planet. We're talking about the fundamental forces that shape our world, the very basics of our climate system.
Have you ever asked yourself, why is it absolutely freezing on a mountaintop but nice and warm down in the valley? Or why do airline pilots always try to fly way up above the clouds? Well, the answers to those questions are all part of the story of our climate, and we're about to figure it all out together. Let's get into it.
All right, first things first. We've got to clear up something that trips a lot of people up: the difference between weather and climate. It's actually way simpler than you might think.
Think of it like this. Weather is what you get. It's what's happening outside your window right now. Sunny, rainy, windy, you name it. It's the atmosphere's mood for the day. But climate? Climate is what you expect. It's the long-term personality of a place, the average of all that weather over, say, 30 years. So, the clothes you pack for a vacation next week, that's for the weather. The wardrobe you own for the whole year, that's based on the climate.
So where does all this action, all this weather and climate actually happen? It all goes down in our atmosphere, Earth's very own protective blanket.
I mean, this thin envelope of gas is literally the only thing standing between us and the pure chaos of space. It traps just enough heat to keep us warm, it shields us from nasty solar radiation, and, oh yeah, it gives us air to breathe. Seriously, without it, Earth would just be another lifeless, frozen rock floating around out there.
Now, here's what I think is so wild. Take a look at what our air is actually made of. It's almost all nitrogen and oxygen. But then you see this tiny, tiny little sliver for carbon dioxide, just 0.04%. It looks like nothing, right? But that minuscule amount plays a massive, outsized role in trapping heat and keeping our planet's thermostat just right.
And this atmosphere isn't just one big blob of air. Nope, it's actually stacked in 5 different layers, and each one has its own unique character. As you go up, the temperature does this really strange zigzag. It gets colder, then it gets warmer, then colder again, and then way, way hotter near the top.
Let's just take a quick trip up, shall we? We're down here in the troposphere, that's where all our weather happens. Climb up into the stratosphere, and you'll find the ozone layer and jet streams. Higher up is the mesosphere, where meteors burn up into shooting stars. Even higher, you have the thermosphere, home of the beautiful auroras, and finally, the exosphere just kind of fades out into space.
And that right there answers one of our first questions. You know why your flight gets so smooth once you reach cruising altitude? It's because the plane is up in the super stable stratosphere, flying high above all the turbulent weather churning around down below in the troposphere.
Okay, so what's the fuel for this entire climate engine? Well, it all comes from one place, the sun. Let's take a look at how Earth manages its energy budget.
The key word you need to know here is insolation. It sounds technical, but all it means is the incoming energy from the sun that actually reaches our planet. That's it. This is the fuel for everything we're talking about.
So, how does Earth not just keep getting hotter and hotter? It's all about balancing the books. Let's imagine 100 units of energy arrive from the sun. As you see here, about 35 of those units get reflected right back into space by bright surfaces like clouds and ice. The other 65 units, they get absorbed by the ground and the atmosphere, and that's what warms our planet.
So that's the magic number, 65. To keep things stable, Earth has to send those same 65 units of energy back out into space. It's a perfectly balanced budget. What comes in must go out. This balance is the absolute key to having a stable climate. But here's the plot twist. While the planet as a whole is in balance, different parts of it are way out of balance. The tropics get way more energy than they can radiate away, so they have a surplus. Meanwhile, the poles radiate way more heat than they get, leaving them with a deficit. And this imbalance, this is what drives pretty much all our weather.
So if you've got too much heat in one place and not enough in another, what do? You move it around. And that brings us to the planet's incredible circulation engine, the wind.
When you get right down to it, wind is just nature trying to balance things out. It's just air moving from areas of high pressure to areas of low pressure, trying to spread that heat from the tropics out toward the poles. That's all it is. And this movement creates 2 main types of weather systems we see all the time. You have low-pressure systems where warm air rises, cools, and makes clouds. That's your stormy, unsettled weather. Then you have high-pressure systems, where cool air sinks down, giving us those clear skies and stable, beautiful days.
Now, on a global scale, this whole push and pull creates these amazingly predictable bands of pressure and wind across the planet.
You can see the low pressure on the equator, the high pressure in the subtropics, and these major winds, the trade winds, the westerlies, and the polar easterlies, that are constantly flowing between them.
Scientists model this whole thing with what they call the three-cell model. You have these three giant rotating loops of air in each hemisphere. There's one cell that lifts hot air from the equator, a middle one that gives us our weather, and a third one circulating that freezing air up at the poles. They all work together like a massive planetary conveyor belt, constantly shuffling heat around the globe.
Okay, so let's bring this all home. Let's take everything we've talked about, the sun, the atmosphere, the winds, and see how it explains why some places on Earth are hot and others are cold.
It really boils down to four main things. First, your latitude, basically how far north or south you are from the equator. Second, your altitude. Remember the freezing mountaintop? Third, whether you're close to a huge body of water, because land and water heat up and cool down at very different speeds. And fourth, those giant ocean currents that act like rivers of warm and cold water.
And this is where you can see it all in action. Look at these two maps of global temperatures. On the left, in January, see how the cold temperatures dip way down over the continents but bend north over the warmer oceans? Now look at July on the right. The pattern totally flips. The land gets scorching hot, and the oceans stay cooler. You are literally watching the planet breathe with the seasons.
So, from the thinnest layers of our atmosphere to the deepest ocean currents, our climate is this incredibly complex, finely tuned dance of energy and motion, all working together to maintain this amazing balance. Which leaves us with one last big question to think about. What happens when we start messing with that balance?